Right, guys, we looked at measures of central tendency, those central values, mean, mode, and the median. Now we're going to look at the measures of dispersion. That gives the spread out of data, which is the range and the interquartile range. Okay, so these are the most common measures of dispersion. Dispersion meaning the spread out of data. Here we go. Measures of dispersion help us to determine how data is spread around the mean or median. This enables one to establish whether the data is grouped closely or scattered more widely. The measures of dispersion are range and quartiles. In this case, I mean interquartile range. Then the range. How do we get the range, guys? Mustn't waste time on this. Range is highest minus lowest. Okay, let's say you're comparing two classes. Class A, the range is 9. Class B, the range is 4. Okay, it's common to say, okay, again, Class A, 8. Class B, 4. You cannot say Class A because it has the range of 8 performed very bad because the range is big. Yes, normally if the range is big, we say that class performed bad. But be careful. Do we have extreme values in that class B that gives, or one extreme value that gives that range of 8? Consider that as well. But normally, under normal circumstances, we'll say bigger range means poor performance. Whereby smaller range, it means your data, there is a relationship, strong one. The data is closely packed, close to each other. Okay, close to each other, they are very close. Whereby those ones are scattered all over. So we tend to say this class A with 4, with the range of 4 is consistent. Okay, the performance is consistent. Be careful when you use the range, because sometimes you may be asked to justify your answer using range, quartiles, and so on. This is what I'm saying, measure of dispersion. Cool. Now, consider, for example, the following set of marks for class A. Now, range, as I said, highest minus lowest. I know that you're bored about this, you know it very well. Quartiles. Quartiles are measures of dispersion around the median, which is a better measure of central tendency. The median divides the data into 2 halves, then the quartiles into 4. Fine. I'm on my way to interquartile. There are therefore 3 quartiles. We call lower quartile Q1. This is found in the lower fence. This is the median of the lower half, meaning lower fence. Good, it's fine. It's the middle of the lower half. The median Q2, this is the value that divides the data, the whole data set, into halves. Now, the upper quartile, which is Q3. This is the median of the upper fence, or the upper half of the values. Now, look at this. We're going to find the quartiles of this. Fine. Calculate the interquartile range. Interquartile range, guys, it's your the data must be arranged in ascending order first, then it's your Q3 minus your Q1. That is interquartile range. Okay, fine. If you look at this, this is my median. This is my quartile 1, quartile 2. My median, another name for median is quartile 2, and quartile 3 or upper quartile. Quartile 1 or lower quartile. So, I first divided my data into 2 halves, median. From there, I look at this part. This from here all the way to there. So the median of this is 2. 2 is halfway. If you look at it, it's halfway through. And then I come again, the upper fence or the upper half. 8 is halfway through. So upper quartile, second quartile, and quartile 1. Cool. Now, median, as I said, quartile 1, 2, upper quartile 8. Those are the values. Fine. Now the interquartile range will be 8 minus 2, which is 6. Happy? Look at this. The breakdown of salaries for the staff. Factory A and Factory B. We have this managing directors, so much per month. How many workers? Then this is the total of them. I've got 2 factories there with the salaries here. Okay, how many workers in the middle? Then total of them. Okay, so like here, 4,500 for 28 workers, then they get this in total. The factory has to pay this. Okay, Factory A, Factory B. Good. So what do we want about this table? Calculate the mean salary paid by each factory. Okay, mean salary I'm coming here. Okay, meaning I need to add all this together. 1, 2, 3, 4. I need to add all this plus 0 as well. But how many? Remember, you add the total. I cannot add only this. Okay, it's 22,000 for 1. It's 22,000, it's fine. But 15,000 times 230. This is already my total. I just add this. Then I get it. And then out of how many workers? My workers, I come here. Okay, that is factory B. I do the same with factory B. Factory A and factory B. Let's look at factory A. I added 22,000, 30 for 24, 12 plus 0 over 36. Add them over 36, number of workers. This is the mean salary, 5,444. Factory B, add all this. Divided by how many workers? 34. If you go to the table and look at number of workers for factory B, 34. Add them, then the mean salary is 4,824. Okay, mean, okay, can come like in different situations, salaries, rainfall, and so on, as we did in this. Then from here, we can compare the situations or the factory using the statistical terms. We'll look at this in the next segment.